Presentation with the first talk about the Sen4CAP system, and it's a big pleasure for me to be here after 4 years. I've tried to summarize the main achievements of the project, and I will show you them today. So as Jean-Luc and Benjamin already nicely explained, so the story of Sen4CAP started some years ago when it was decided to rely on the Copernicus Sentinel data to modernize and simplify the CAP. And so this link between technology and policy was really a challenge. And Sen4CAP was one of the very first pilot project that tackled this challenge. So the objectives of the Sen4CAP project were twofold. And first, it was to provide evidence that information derived from Sentinel-1 and Sentinel-2 could be useful, could support this modernization of the CAP. And then in a second time, when the evidence is provided, the project aimed at providing the CAP community with algorithms, products, tools, best practices on how to exploit these Sentinel data in a relevant way for the CAP monitoring. So the way the project is structured has already been introduced by Benjamin. I must say that we worked with 7 pilot paying agencies, and these pilot paying agencies have been involved since the very beginning of the project, and this link with the pilot has been really instrumental for the project. So Sen4CAP has been following a user-driven approach since the beginning. It means that the expectations of the users were taken on board in the very first months of the project. So we had a user workshop in July 2017, where the paying agencies explained us what they would expect from Sentinel data. Of course, the context was a bit different than now, because we were in another framework. But this link with the expectations and the requirements from the users has been maintained throughout the project. It has ensured that what was developed by us was useful, was answering very specific questions from the paying agencies. And so this has been really important for the achievements of the project. So during this first user workshop, we try to define the main requirements of the users, and these requirements were expressed in terms of use cases, meaning specific applications in which the added value of Sentinel data had to be demonstrated. And these use cases were all related to the greening payment. So you can see them here. This is crop diversification, identification of permanent grassland with the mowing, and the monitoring of some IFA practices. There was also a specific request for having a tool allowing interactive visualization of the Sentinel data and the product, because the paying agencies were convinced that they needed this tool to better understand the Sentinel data value. And this understanding of the data would be very important to gain confidence in the new technology. And so this is the framework in which we have been working within Sen4CAP. Of course, there are many more things to do, but this is the framework of the Sen4CAP project. And based on these use cases, the consortium has defined 4 kinds of EO products, which you can see here, that could allow being efficient in these use cases. So there are crop type maps, growing vegetation indicators, detection of grassland mowing, and monitoring of some IFA practices. So the project was a project of 3 years, and it was organized in 2 main phases. The first phase was really about pure R&D, so the selection of the use case, then specifying the EO products. For each product, we compared different methodologies. We derived prototype products, and these products were presented to the users, to the steering committee. They were discussed. And at the end of this first phase, we had a first version of a tool, the Sen4CAP tool. And we were ready for the second phase of the project. And the second phase had the objective to demonstrate these tools, these Sen4CAP tools, at national scale. So in the first phase, we were working over small areas, and in the second phase, we scale up at national scale in most of the pilot countries to test also the robustness of the system and its validity over a full country. So we also tested the continuous monitoring during this demonstration, and we put a lot of effort in the validation of the products and the assessment of their fitness to use. So during this demonstration, which lasted 2 years, but in fact was continued last year in 2020, we validated the product. We assessed what was good, what was less good, what needed to be improved to be really useful for the pilot paying agencies. And this is this assessment which allowed improving and fine-tuning the algorithms that were developed in the first phase. Another strong activity from phase 2 was the capacity building and the training. So we are convinced that this is absolutely needed to facilitate the uptake of a new technology. And so we visited the pilot paying agencies. We have organized trainings about the methodologies, the products, and all these interactions really contributed to the improvement, the continuous improvement during the project. This second phase was done all on DIAS, on Creo DIAS. Each country had a virtual machine, separate virtual machine where the production was done, and they had also a smaller machine where they could play and learn the system. So what is the Sen4CAP system? This is the diagram. I think you have already you have already seen previous version in previous presentations, but this is the last version of the diagram corresponding to the last version which was delivered in February this year. So this is an open source system which tackles all the steps of the Sentinel-1 and Sentinel-2 processing, starting from the reading or the downloading of the data. Then there is the pre-processing, which is optional for Sentinel-2, but mandatory for Sentinel-1 to derive amplitude and coherence. And then from this pre-processed time series, you get the database, markers database, which is built. And finally, these markers are interpreted into varying products, the products that I have mentioned before, along the season. So this is a system which tackles all the steps, but which is also very modular. So you can use specific modules, the modules you are most interested in. You do not need to run everything to be a Sen4CAP user. This is modular, and this is also automated, meaning that when you parameterize your system at the beginning of your monitoring season, all the processing is handled in an automatic way. This system has been demonstrated continuously along the season, but it can also be run at the end of the season offline. And it has been shown very efficient for national scale processes, showing its robustness. It can be operated locally or on the cloud, and something which is new in this version 2 is that the main components are now available as Docker image, which will make the installation easier for the users. A key aspect of this system is certainly the markers database, which is new from this version 2. So the system is generating a large data set of markers from Sentinel-1, Sentinel-2 at parcel level and along the season. You can see here, this is a very high number of features that are computed each week or each 10 days and that are filled in the database, which is growing along the season. So this is another illustration, another representation of this markers database. So the markers are are derived from Sentinel-2, reflectance values, vegetation indices, biophysical indicators, from Sentinel-1, amplitude and coherence time series. And of course, it relies on the subsidy applications which are provided by the paying agency to the system to compute all these markers at the parcel level along the season. Then within Sen4CAP, these markers are interpreted into a crop type map. They are used to detect grassland mowing and to monitor agricultural practices. And the validation within Sen4CAP has been done within this framework. But of course, we know that these use cases are only a part of what needs to be done by the paying agencies in the IACs. And so we wanted that this markers database be accessible for other uses. And so now it is fully possible to directly access the database through an API interface. And then it opens the possibility to many other applications. So you can develop your own application outside of the Sen4CAP system by yourselves, only using the markers database that exists. I will now spend some slides, some minutes to present you some products, the different products that can be generated by the Sen4CAP system, and we will start with the land cover map, the crop type map. So this is an example here of a national crop type map over Czech Republic from this year, 2020. So we use 6 months of data to generate the map. You can see this is a high number of markers derived from Sentinel-1, Sentinel-2. The overall accuracy is quite good, and almost all the area has been assessed. So 99.5% of the area has been assessed. So with this crop type, so the crop type is provided with a confidence level, and it can be compared to the declaration to have a kind of conformity assessment at the parcel level. And you can see here the different figures, which are quite realistic when compared to the feedback of the paying agency. This is another example of crop type map. Here we are in Lithuania. Also more than 100 crop types, and the overall accuracy is close to 90% again. So we had the same level of accuracy in 2 successive years, 2019 and 20, showing the reliability of the algorithm. And what is interesting here in Lithuania, it's to see that the for the F-score, so the performance for the 9 main crops is quite high. These 9 main crops covering 92% of the surface, so it's really emphasize the usefulness of the map. As I show you, for Czech Republic, the map can be used just to assess the conformity at the parcel level, but really in terms of impact for the paying agency, this is the crop diversification assessment, which is the most important, which is done at the holding level. And here, just with very simple rules, which have not been fine-tuned by the paying agency, we can see that the use of this map allows supporting the decision in a very high proportion of dossiers. So another interesting observation with the crop type map is that we get already very high accuracy early in the season, so at the mid-season, basically from May, June, in most of the countries and for many crop classes, we start reaching a plateau in terms of F-score, in terms of accuracy. And so it means that the map can really support a continuous monitoring as soon as the month of June, and this is quite interesting in the context of continuous monitoring. So based on this statement, we tried to go one step further with Lithuania. So the Lithuanian paying agency asked us to test early classification, so early meaning before May, to see if it could support a claimless system. So this is linked with use case in Liva. And so here we are performing the test, which is still ongoing. So these are not the final results, but just to show you that what is done. So we are using the applications from the last year, and we are running classification using basically the winter month to see if we can get a reliable crop type map to propose to the farmers when they do their subsidy applications. And so different 2 legends are tested. So 4 main classes for the simple one: annual crop, grassland, permanent crop, and fallow. And then a second legend where we add also the other natural areas and the greenhouse and nursery. So for the moment, with a map from the 1st of May, the overall accuracy is close to 85%, and the best results, the best accuracy is obtained for 2 classes, arable land and grassland. But as I told you, so the test is still ongoing, and so we hope to refine it a little bit more. I'm now moving to the second product, which is the detection of mowing events over the grassland parcels. So this detection is based on the analysis of Sentinel-2 vegetation indices time series and on Sentinel-1 currents time series. So the algorithm behind the detection is looking for a decrease of the vegetation indices and an increase of the coherence just after the mowing event. So the product that you get is just for illustrated here on the right. So for each grassland parcel, you get the number of mowing events which has been detected. And for each mowing event, you get the date of the detection, so the interval, then the confidence level of this detection, the satellite vision which was used, and at the end of the season, you get also the compliancy level. It means that we compared the number of mowings and the dates of the mowings that were detected with the national regulation, and we see if this is compliant or not. So this is an example in Castilla y León of mowing detections based on Sentinel-2 NDVI. So Sentinel-2 NDVI is of course, in Castilla y León, there are very few clouds, and so we have a very nice profile, but so we can see that we have 4 decreases of the vegetation in the indices. And when we compare to the planet data visually, we can see that for each date, we observe a mowing. And so the detections here in this case are confirmed. So this algorithm was run in the different demonstration years. And so from 2018 to 2019, we managed to improve a lot the accuracy of the algorithm and more specifically the precision. So you can see this is the red bar, and which is always higher in all the pilot country than the yellow bar in the graphics. Still, there are things to improve, and we have observed in the different use cases that we did that the performance of the processor is still impacted by 3 factors, which are the grassland drying, mainly in the Mediterranean context. So the drying of the vegetation is confused with the mowing, and so it decreases the accuracy, the precision of the detection. We have also the confusion with grazing, and this is very difficult depending on, of course, on the intensity of the grazing, but this is really difficult to make the difference between both. And we have the challenge of the partial mowing. In Sen4CAP, we are working by parcel, and so when the mowing is applied on a small area within the parcel, so the detection is not ensured with the current algorithm. I move to the third product, which is the monitoring of agricultural practices, for which we define 10 markers that are related to the state or the change of the vegetation at the parcel level. You can see the markers here. So there are 5 markers for the detection of the harvest and 5 other markers for the monitoring of the practices. These markers are derived from Sentinel-2 NDVI, but also from Sentinel-1 backscatter ratio and coherence VV. So what we do with this processor is that we perform a weekly monitoring of all these markers. First, the harvest markers, because the harvest of the main crop is a precondition for the IFA practice. And so when all the markers of the harvest detection are true, we identify the week of the harvest, and which is the blue line that you see here on the graphic. And then from this moment, we activate the markers for the IFA practice, and these markers check if there is a vegetation which is growing and which remain in place within a certain period, this period being defined by the regulations in the different countries. Running this processor over all the pilot countries in 2019, we were able, in fact, to monitor the evolution of the harvesting in the different countries and for the main different crop groups. So this was a really interesting results, showing the robustness and also the consistency of the algorithm within the diversity of agricultural landscape in Europe. Something which is new and which is associated to the agricultural practices monitoring is the detection of tillage applied after the harvest of the main crop. So this is new in the version 2 of the system, and this is using the markers defined for the harvest. So I will not go into detail now because this algorithm will be presented to you in detail tomorrow during the technical session. So that was for the, let's say, the main project of 3 years, where we did R&D and then we demonstrated by scaling up national scale during 2 years. After the end of these 3 years, we had quite positive feedback from the pilot paying agencies, and they were asking for more support. So they needed more time to better understand the technology, better understand the tool. And we had basically the same requests from other paying agencies, which were not in the pilot selection. And so, as Jean-Luc explained, so ESA agreed to give us 1 more year, so to extend the project. And here, the focus of this extension was really to work on the uptake of the new technology by all users. So not only the pilot countries, but really all users. So this uptake, of course, we continued with the pilot countries in 2020. And so there were very nice progress in the technology uptake. So in Castilla y León, the Sen4CAP system is running in their own premises and operated by themselves. In Netherlands and Italy, the system is also operated by the paying agencies on CryoDias this time. In Czech Republic, Lithuania, Romania, the Sen4CAP has been operated by us, but the paying agencies at the same time invested a lot in the validation of the products to gain a higher understanding and gain better confidence in the tools. And in France, the last year was the opportunity to improve the link between what was developed in Sen4CAP and in NIVA. So I will not tell you more about that because you will get presentation about them during the next session. I will just show 2 slides from 2 countries who will not present. So the first slide is about Italy. So just to show that they are running a Sen4CAP on 6 sites, which you can see here. So this is quite significant. And on these 6 sites, they are running Sen4CAP for the pre-processing of Sentinel-1, Sentinel-2, for the crop type mapping, and also for the grassland mowing detection. So the processing is close to its end, and so the analysis of the product is ongoing. In Czech Republic, so in 2020, we run the product for the paying agencies, and the paying agencies invested a lot in the validation of the product. So here, I can show you some slides with the permission of the paying agency showing the exercise they did in qualifying the results obtained by Sen4CAP following the standards from GRC. And so the conclusions were very satisfactory. And I think that all this exercise of validating, spending time on understanding how it is working with Sen4CAP, but also with other projects in which they are involved, allow them really gaining confidence in the new technology, and I think that it will allow them to move to the CAP by monitoring, to the control by monitoring very soon, which is a good news because this is, of course, the ultimate objective for each paying agency. So these were for the pilot paying agencies, but of course the uptake was also aimed for the wider community, and we can say that we managed to do it quite well. So the Sen4CAP system was downloaded 330 times since November 2019 in most of the European countries, but also outside. So there are some interest outside. So the project granted test virtual machine on CryoDias, where the Sen4CAP system was already installed. This was for paying agencies who just wanted to see what was this Sen4CAP system, that wanted just to discover it and assess a bit if it could be useful for them. So I think this experiment was quite a success. This was easy for the paying agencies, and for us it was a good way also to get feedback on the system. And I think that based on this experiment, it facilitates the decision to use or to at least get inspired by what was done in Sen4CAP to make progress on the monitoring system. I must also say that the Sen4CAP system is offered as a service on DIAS currently, so this is possible to continue. One slide from Denmark, which was one of the countries that tested the Sen4CAP system on the test virtual machine. So this this testing phase, I would say, allowed them to work on one Sentinel-2 tile and to test the L4C processors for the maize harvest detection. And so I will not go into details. This presentation was done by the Danish paying agency during the 5th webinar, and you can get the full story by listening to the recording, which is available online. The conclusion was that the maize harvest can be predicted with high users and producers accuracy at the end of the season. Of course, there were some sensitivity of the algorithm that needed to be better understood and managed, but the results were promising enough to convince them to explore a bit more the Sen4CAP system during the next year. So to facilitate the uptake, something is very needed. This is capacity building and user support. And so this is what we try to do since the very beginning of 2020 with the organization of a physical training in Belgium. This was a big success, 44 participants from 20 different countries. We all met during 3 days. So we interacted on methodology, but mainly on the tool with hands-on training in a computer room. And we had very fruitful discussion on what could be useful, what was missing. And so this was really the start of hearing feedback from the wider community and guiding the evolution of the system on our site. We continued the training, but then in an online version in April 2020. Again, big success, more than 100 participants. We had to repeat the sessions because we wanted to keep small groups to allow interactions. All resources of this training are made available online. So this is something that if you were not there during the training, you can always catch up. And this is in fact the same for all resources of the project, all presentations, all webinars, everything is made available there. We also set up an online forum where we have around 90 active users. You can see that the activity is the forum is always active, of course, with more activity when we deliver new versions of the system. We support our IT team, our IT partner is supporting also individualized support, meaning that when there is something that needs to be fixed, sometimes they directly ask the access to the virtual machine on which the users are working, and they can directly help the users in that way. And finally, in terms of capacity building, what we started and what we did during all the year is the organization of regular webinars. So we had 6 webinars up to now. I think this is my personal feeling, but I think that this this webinar activity has been really very useful to build a kind of community. This was really the place of interactions collaborations between the participants. So at the beginning, this was more the consortium presenting the Sen4CAP system to the users, and in the last webinars, we had users presenting their own experience with the system to the audience. And I think this kind of interactions are really useful and are really needed, in fact, in the process of technology uptake. These webinars and the forum are also useful for us to get feedback from the users to see what needs to be evolved in the system. And here, one slide for one example. We had a request from the northern countries saying that the Sen4CAP system cannot be operated in their countries because we were using the SRTM, which stops at 60 degrees north. And so they asked us to provide, to update the system to make it compatible with other DEMs. And this is what we did with 2 DEMs. So the Copernicus EU DEM and the Astor DEM, which can now be used instead of the SRTM. In 2020, we tried to build better links between the Sen4CAP and the NIVA projects. So now Sen4CAP is used in NIVA as a starting point or as a building block in different use cases. There is one example that will be presented this morning by our French partner about the use of the Sen4CAP markers in agri-environmental indicators. So I will let this content for the next session. Sen4CAP is also used as starting point in a new ESA project, which is started now, which is the EO Widget project. So EO Widget is a project that plans to go one step further than Sen4CAP, meaning that Sen4CAP has been developing tools and then it stops at the product level. And the EO Widget is also planning to run algorithms to generate products, but to go one step further and to facilitate the integration of these products into the IAC cycle through API, through applications, what they call widgets. And so the basis of the algorithm, the starting point for the algorithm will be the Sen4CAP algorithms. Of course, they plan to make evolve them, but they will be the starting point. And finally, just to say that the Sen4CAP system was also used in the RACE initiative from European Commission ESA. So RACE is a platform where the impact of the COVID lockdown on the society was assessed using Sentinel data. And so there are different kinds of indicators about the air quality, for instance, or the traffic, and about agriculture. One use case was done with Sen4CAP, where we monitored the harvest of the winter cereals in Spain to see if there were any delay or disruptions that could be explained by the lockdown. And so to do that, we run Sen4CAP, the L4C processor, so the harvest monitoring with the markers, and we run it at national scale on DIAS in near real time during the season. And you can see the two kinds of indicators that we generated. So the first one was the evolution of the harvest over time, so where the indicators were updated regularly. And the second one is the comparison of this evolution with the previous year to be able to detect any anomaly. Well, the conclusion was that there was no anomaly, which finally was a good news. So the lessons learned from all these 4 years of activity. First, in terms of tool, so the Sen4CAP is an open source system, which is providing markers from Sentinel-1, Sentinel-2 time series, markers which are at the parcel level and which are computing along the year. These markers and the EO products that are derived from these markers have been assessed nationwide in a selected set of use cases. But this assessment has been done in 7 pilot countries and for 3 successive years. So it gives insight in the reliability of the methodologies that are behind. So the Sen4CAP can be run in real time or offline, on the cloud or locally. The system is tackling all the steps of the Sentinel processing, but it is also very modular, meaning that you can select the different components in which you have the highest interest. And the new concept of markers database, which was developed during the last year, really opened the floor for new applications, supporting more sustainable agriculture and supporting maybe the pillar 2 of the CAP. In terms of uptake, so there is a wide uptake of the system, the full system of its individual modules. We can see that it was downloaded many times. We got very nice feedback from paying agencies just to testing the system. It was inspiring for many paying agencies, the work that was done in the project. We did a strong effort in capacity building to support this uptake. We think this is really essential. And as Benjamin mentioned, so the maintenance of the Sen4CAP system will be ensured thanks to ESA and the new project that they launched, which is the Agricultural Virtual Lab. The main lessons learned probably from this project is that a long-term user support and tools maintenance are 2 key conditions to allow technologies transfer. So the uptake of new technology is a very long process, and the users need to be supported throughout this process, and in that sense, just having support during the project lifetime is probably a bit too short. And so this is the objective also, to see how we can continue offering this support. If we come back to the initial objective of the project, which was to support the move to the new technology, we can say honestly that Sen4CAP has met the objective. So this is a powerful tool which has supported the process of moving towards the development of new monitoring system. So the paying agencies had the opportunity to test Sen4CAP, to integrate modules of Sen4CAP, or at least to get inspired by what was done. And so in any case, this contributed to the move to the monitoring system. We think also that the collaborative approach that was used in Sen4CAP has clearly contributed to this to the uptake of this new technology. And so I really thank you, all of you, just to conclude my presentation, for all the fruitful interactions we have had so far, and I hope that will continue a bit, because the achievements of the projects are also, you made them also possible thanks to all the interactions we had during the project. Thank you very much, and I will stop here the presentation. And in fact, I'm also chairing the meeting. So I don't know if there are... I propose to keep the question for later on. So all the questions in the chat are kept. And so I propose to move to the second, the next session, which is the session about the pilot countries. I will.
Thank you, Sophie, for your talk.
I think we can start. So there will be 4 pilot countries presenting. And so following the agenda, we will start with Netherlands. And then we will go to Lithuania, Castilla y León, and France. And so